Thank you, Magda. Hello, everyone, and welcome to this new GRAPHIA webinar. Thanks a lot for joining. Um, as Magda has already said, I am Julien Homo. I am a data architect and the CEO of Foxcube, which is a French company based in Paris and specialized in graph technologies and semantic artifact at scale. And in GRAPHIA, I am also the technical coordinator, so I help shape the overall architecture and connect the dots between the partners and the technical work. Today is very pragmatic. We are not doing what is a knowledge graph in theory session. We will focus on concrete SSH research stories and what becomes possible when data is connected through entities and relationships rather than staying as isolated records. So concretely, we will cover why a knowledge graph matters for SSH, which kind of research question become possible when things are connected, also how to frame those questions so they are buildable. We will call competency question, I will explain. And finally, how Graphia turns those stories into services and infrastructure. So if you work with SSH data as a researcher, an infrastructure person, a developer, or a service provider, or just by curiosity, and you are interested in SSH knowledge graph use cases, you are exactly in the right place today. All right, just to give you the roadmap for this webinar, we will start with a very quick reminder of the knowledge graph basics, just enough so we are all aligned on vocabulary. Then I will clarify what we mean by a knowledge graph use case. After that, we will spend most of the time on SSH in practice, a set of realistic Graphia scenarios across different families of use cases. And then I will step back and show how Graphia supports these use cases. And of course, we will have our Q&A session at the end of this presentation. So before we go into use cases, I want to clarify one thing. Knowledge graph is a very overloaded term. Depending on who you talk to, it can mean different things. Sometimes it's a conceptual model, sometimes it's a graph database, sometimes it's a ontology with RDF, or sometimes it's simply a strategy for integrating knowledge graph across systems. So when people say we have a knowledge graph, it's not always the same object. And that is actually a strength. The concept is flexible, but sometimes it also creates confusion because we may use the same words for different layers. That's why for today, I will use a simple shared reference definition. A knowledge graph is essentially a graph of data meant to represent real world knowledge where nodes are entities or concepts and edges are the relations between them. And in the rest of the talk, you will see how Graphia uses that idea in a very practical way, not just a graph, but a way to connect SSH evidence so we can ask better questions across sources. All right, maybe one thing before also, because we will say the term graph and knowledge graph all the time, so maybe it's better to define it properly. At the most basic level, a graph is just a mathematical shape, nodes and edges. It only tells you who is connected to whom, nothing more. That's why you can model a metro map, a protein network, or your LinkedIn connection with the same structure. But here is the key point. Most graphs are not knowledge graphs, because in many graphs, you don't really know what the nodes mean. You just have A connected to B, but what is A? A person, a place, a dataset, an event? We don't know. And what does that edge represent? Without context, it's just a structure. So when we say knowledge graph, we mean graph and meaning. You add identity, what each node actually is, and semantics, what each relation means. In other words, the graph becomes interpretable and queryable in a way that's closer to knowledge, not just connection. A simple way to picture it, a metro map is a graph, but a GPS system where places are identified, routes are typed, and everything has context, that starts to look like a knowledge graph. A contact list is just connections, but a CRM that knows who the customer is, their story and intent is a knowledge graph. And linking actors to films is already a graph. But when you add things like who directed what genre it is, and when it was released, you are clearly in a knowledge graph territory. And this is exactly the jump we are interested in for SSH. Not only, okay, things are linked, but we know what they are, why they are linked, and what we can infer or retrieve from those links. And with semantics, you move to a different level. You can align and enrich data from multiple sources. You can infer patterns. You can explain why a result is there. It also enables practical things like query expansions, matter recombination, and of course, explainable AI. So before we move on, just a quick note. I would like, if you like a deeper walkthrough of knowledge graph fundamental and basics, we already covered that in our first GRAPHIA webinar. So if some of these basics are new, or if you want the full step-by-step version, the recording is available on YouTube. You can either use the link or simply scan this QR code on the right, and you will land directly on the video. So with that reference in mind, let's turn to today's topic, I mean the concrete GRAPHIA use cases. Before we talk about a knowledge graph, I want to align on one simple thing, what we mean by a use case. In software engineering, there is a very standard definition. It basically say a use case describes how a system behaves when someone asks it to do something under different conditions. So it's not just an ID, it's a clear interaction between people and a system. But for today, I like to translate that into something very practical. A use case is a short, concrete story. And that story always comes down to three simple questions. First, who is the primary actor? Second, what are they trying to achieve? What is the goal? And third, what does success look like, the outcome? Here is a simple example in SSH. Imagine an historian studying intellectual influence in 19th century Europe. The goal is to identify and justify pathways of influence between thinkers using the sources that are available. And the outcome is not a feature. It's something tangible, a documented analysis, a report, or a narrative that sets evidence for the influence being claimed. So that is the framing we will use throughout this webinar: actor, goal, and outcome. Once we have that, we can start asking what kind of connected data and what kind of graph is needed to support it. Here, I'm just adding one small step. In the previous slide, we had a use case, a person, a goal, and an outcome. Okay, a knowledge graph use case is when we take that same story, but we also make explicit the questions we need to answer to reach the outcome. So it becomes actor and goal with outcome plus questions. And those questions are important because they immediately tell you what must be connected. If I reuse the same example, it's the same historian and the same overall goal, understanding influence. But now the goal is phrased as question like who is connected to whom, through what evidence, across which places, and which periods. And the outcome is not longer just a report. The outcome becomes a knowledge graph where people, letters, works, and places are linked with stable identifiers and evidence-backed relations. So the historian can actually query and validate influence pathways across time and geography. So finally, the key idea is simple. A use case defines the outcome, a knowledge graph use case defines the outcome and the question the graph must answer, because that is what drives the relationship you need to model. So if we take the definition we just built, a knowledge graph use case is also the question you need to answer, because those questions tell you what kind of connection and meaning you need in the data. A practical way to sanity check this is to ask, does my question actually depends on links, identity, or concept? If yes, you are typically in knowledge graph territory. There are three common patterns. First, multi-step question. If you don't get the answer in one job, if you have to follow a chain of connection, maybe you are in the knowledge graph territory, like find house bonds in cities that were under Prussian rule in 1850. That's not one lookup, it's traversal. Then a second common pattern is about identity. Who is who? The same person or institution appears under different names across sources. So if your question requires reconciling variants and usable stable identifiers, that is very knowledge graph shaped. For instance, aggregate all funding received by one researcher despite name variations. And third, concept-aware research. You are not looking for literal keyword, you want the meaning. If you ask for example, religious buildings, you also want cathedral, mosques, synagogues, because they are subtypes of the same concept. So the rule of thumb is simple. If the value is in following links, resolving identity, or using the concept layer, then a knowledge graph is usually the right tool. Okay, so here the next step is, once you know your question needs a knowledge graph, you still need a way to turn that need into a clear requirement. Because saying, build me a history graph is not actionable, not at all. It doesn't tell you what the graph must contain, what links matter, or what don't mean. That is exactly why in the knowledge graph world, we use competency question or CQ. They are basically the functional spec for the graph. And a good CQ, a good competency question, forces three things to be explicit. First, the input. What do we start from? What do we already know? For example, given a specific author like Hannah Arendt. Second, the path. What relationships do we need to follow to answer the question? So, for example, find who influenced her and who she corresponds with. Third, the output. What do we want back? What does the result look like? For example, return a network map of these people. But input, path, and output. So at the end, the competency question acts like a contract. If the graph can answer the specific question, then the design is valid. And if it cannot, you immediately know what is missing. Great. So once you have competency questions, you quickly notice something. Most of them fall into a small number of recurring story patterns. The first one is connect and integrate. That is typically a data provider saying, I have heterogeneous sources, and I want them connected into a one coherent graph so researchers can use them together. So here the focus is ingestion, alignment, and interoperability. Then you have also enrich and make it explicit. That is more the curator angle. I want to extract missing entities, links, or metadata, so the graph becomes richer and more reusable. So here we are talking about extraction, linking, and semantic enrichment. A third family is explore and answer questions. This is the classic researcher workflow. I want to navigate connections and ask more complex questions across sources to build and test hypotheses. So here we are talking about multi-hop, identity, and concept search, as I have previously explained. Then we have also trust, provenance, and quality. That is the steward perspective. I want to know where the data comes from and whether I can trust it. So reuse is auditable and compliant. And the last one is about analyze the network. That is when the researcher wants to run graph algorithm, for example, centrality, communities, similarity, to detect patterns and structures in a field. So here, we are talking about analytics, clustering, or embeddings. So as you can see, different stories, but at the end, the method is the same. For each family, you write the competency question that make the requirements testable. So before we jump into the examples provided in GRAPHIA, let me quickly connect the dot with this recap. We start with a use case as a story. So we have an actor, a goal, and an outcome. That is the human side, what someone is trying to achieve. Then when it becomes a knowledge graph use case, we keep the same story, but we add one key thing, the question the graph must answer, the one that depends on links, identity, and concept. And there is where a competency question come in. They are basically the contract. A competency question is always input, path, and output. What do we already know? What relationship do we need to follow? And what do we want back? And the validation rule is very simple. If the graph can answer this question, the design is valid. Once you do this a few times, you also see that use case repeat the same patterns: connect, integrate, enrich, explore, trust, provenance, analyze. And if you want a quick sanity check, it's still the same three signals. If you have some multi-hop or identity or semantics signals, maybe the knowledge graph could help you in your approach. So to conclude, the use case is the story, the competency question is the blueprint, and the graph is the answer. Based on that, we are able to build use cases, and it's exactly what we are doing in GRAPHIA. Before everything, we are collecting this competency question together in order to understand better why we are building this SSH knowledge graph together. So now that we have set the basic and the method, let's move into these SSH scenarios, the concrete research stories GRAPHIA is designed to support. But before we move on, just one quick thing. So as I said, all the examples you are going to see now come from GRAPHIA, the project we are working on. GRAPHIA is a Horizon Europe project, bringing together 21 partners across 11 countries over 3 years from 2025 to 2027, with the goal, where the main goal is simple, is build a comprehensive knowledge graph for social sciences and humanities and make it usable in practice. So that is exactly why today's use case matter. They are not hypothetical examples. They are the kinds of research scenarios we are actively working on in GRAPHIA to make this infrastructure real and reusable for the community. Um, just to make it concrete, GRAPHIA is delivering a few things in parallel. First, this SSH knowledge graph that brings together data that is currently disconnected. Second, open source language models tailored for SSH. Third, we have also new prototypes and upgrades of existing tools for the SSH communities. Fourth, a software framework to extract, index, and enrich SSH resources, including citation data. And fifth, a set of APIs so these services can actually be reused by others. But for today, the key point is really the last point. GRAPHIA is driven by use cases. We have 14 research and industry pilots at different maturity levels. Some of the examples I will show are directly taken from this specific pilot and prototype, and others are also more transversal. They connect patterns and needs we see across several pilots and across also the wider GRAPHIA infrastructure. So let's start with Genius Loki. Their goal is to produce geosocial indicators like territorial attractiveness, combining local data and SSH publication across different spatial levels. The challenge is that the underlying evidence is scattered, heterogeneous, and uses different concepts and timeframes. So here, the knowledge graph twist is treating territories as first-class entities. So they connect them to the evidence through type links and stable identifiers. And the result, an indicator is not just a raw score. It becomes now computable, explainable, and queryable. Concretely, this is what GRAPHIA brings in 4 different ways. First of all, a concept layer to normalize topics and expand queries. Also entities and place linking to accurate connect location to the right evidence. GRAPHIA brings also an evidence graph, so every score is traceable and auditable. Will bring, of course, and we are still working on it. And reusable APIs to access both the indicator and its justification. So concretely, we are working together, I mean Genius Loki and the GRAPHIA consortium, to facilitate their work to build this use case. And this use case translates perfectly into these competency questions. For a given municipality, what SSH evidence exists for concept X in timeframe T? Or, for example, another one, which connected signals support or contradicts this indicator value, and from what sources? And the last example, which places are truly comparable based on shared evidence pattern? This is one of the different examples we are working or trying to answer. Thanks to this competency question, the knowledge graph has to be able to provide some answer for each part of this question. Moving to ES-Sherry in hollow-cost studies, this other example is based on this context, this aim. The aim is to let researchers explore dispersed archival material as one connected space. The problem is extreme fragmentation. People, places, and events appear under different names across institutions with only implicit links. So doing cross-collection research manually is slow and error-prone. So that's why here the knowledge graph twist makes those entities and relationship explicit. Researchers can finally traverse and validate connection across archives rather than reconstructing paths manually. So what GRAPHIA contributes are 4 building blocks. Again, an entity layer with identifier to reconcile and disambiguate across collection. Typed links with provenance, so every connection is evidence-based, cross-collection querying for multi-op exploration, and of course, auditor limb suggestion where time, place, and context strongly overlap. So this is an important challenge, but this is the main objective to address for this use case with GRAPHIA and the knowledge graph involved in this project. And you can express the expected behavior through this competency question. For example, given a person, which records across institutions refer to them and how they connect? Or, for example, which testimonies mention a specific location in a given time or window? Or finally, if a connection is proposed, what is the exact supporting evidence? Then our third example is about Jay-Z, focusing this time on survey research. Researchers constantly publish papers using specific dataset and variables, but this usage is rarely captured. The problem is asking where was this dataset or variable used is incredibly hard because mentions are buried in the full text. That's why with the knowledge graph, the KG twist here is to use NLP to detect these mentions and publish them as searchable evidence bank links between publication, dataset, and variable. So here, what GRAPHIA brings is the shared interoperability layer. It ensures this link use a consistent model aligned with identifier and connect to the wider ecosystem for API access. So, of course, we have a dedicated team in the project involved mainly to work on it and to use the graph in order to facilitate the job. But GRAPHIA is a key entry point for this team to help them in this approach, to help Jesus to reach this goal. And again, this unlocks specific competency question. Given a data set, which publication used it, and which variables were analyzed? Given a variable, which publication mentioned it, and what is the supporting text snippet? And for a specific publication, which datasets and variables are detected, and with what confidence? I have also another example. This one is a cross-knowledge graph discovery use case, not only dedicated to one specific organization. Here, we are talking about building a diamond open access literature snapshot. So, for example, we have a researcher who need to quickly build a relevant corpus. The problem, relevant papers are spread across multiple scholarly knowledge graphs with inconsistent keywords and duplicate records. So here, the knowledge graph twist is running a cross-source metadata search, then merging, semantically aligning, and deduplicating the result to create one clean corpus. So what GRAPHIA brings is the federated engine, federated retrieval across sources like Open Citation, ORKG, or for example, Go Triple, but not only, all the federated knowledge graph. Concept-aware expansion is also bring by GRAPHIA, so you are not limited by exact keywords. Identifier alignment to deduplicate works on author, and finally, some export-ready outputs. So here, the competency questions are very concrete. Which paper match my keywords across multiple sources? For each result, can I export a clean metadata record with stable identifiers? Which results are duplicates? And what is the canonical record between them? And my last example for this section is about network analysis. Tracing schools of thought. So here, our researcher wants to understand the structure of our research landscape, but not just get a list of papers. The problem is that standard keyword search is flat. It doesn't reveal communities, bridges, or influential nodes beyond for example, raw citations count. The knowledge graph twist takes a relevant subgraph, generates an analytics view, and runs graph analytics thanks to, in our case, Neo4j, to compute communities, centrality, and similarity. So what GRAPHIA brings here is threefold. A curated SSH knowledge graph backbone with solid entities and identifiers, a reproductive pathway to generate the analytics view, and the analytics layer itself for community detection and centrality. So for this workflow, what are the competency questions? For topic X, what are the main author communities and how do they differ? Thanks to the backbone we're about to share, we will be able to share some answer about it. Which author or institution act as key bridges between communities, and which works are central in this network, and what paths explain their influence. It could be another competency question related to this use case. So all of these use cases are built on some competency question. I will explain now how we are turning them into something concrete, but everything is based on competency question. With the different partners involved in GRAPHIA, the first step is to discuss with them which kind of question we are trying to solve, and we are building this question with them in order to build then the knowledge graph itself. And at the end, we will reuse this competency question at the end of the project. I mean, after the development or during the development, we are agile. We are trying to do in that way. But the idea is to use this competency question also to test if everything is okay or if something is missing. So this is our specification, but also this is something directly usable and testable because the competency questions are expressed also in a language we can apply on top of the knowledge graph. Now that we have seen this kind of stories and question a knowledge graph is meant to answer, let's look at how GRAPHIA turns them into something concrete, shared data, shared semantics, and services we want to provide. It will be the final part of this presentation to clarify better, concretely, what exactly we are trying to do to cover all these aspects. To do that, I will share with you this diagram because it's a complex project with a lot of components involved in this GRAPHIA project, but I will explain. So up to now, we have been talking in terms of research stories with real situation and the competency question behind them. This slide, this diagram is the how GRAPHIA turns this question into an operational infrastructure. Before we dive into the database, I want to highlight something very important for us. The layer at the very top that holds this all together, the interoperability framework. This is crucial. It is driven by the GRAPHIA ontology and heavily based on a standard, which is the SKGIF, the Scholarly Knowledge Graph Interoperability Framework. This ensures that our APIs, alignments, and mapping speak a standard semantic language, making trust cross-graph communication possible. Beneath this umbrella, at the center of GRAPHIA is our authoritative semantic core, the place, where facts you can sit live. That core is RDF because we absolutely need stable semantics, traceable provenance, and long-term interoperability. Concretely, we implement this as the GoTriple knowledge graph based on the discovery platform GoTriple, hosted in, which will be hosted in Virtuoso. Virtuoso is operationally mature. It's a solution which handles Sparkle excellently and use name graph for clean updates and provenance boundaries. But it's also important to mention it. We also keep Clever as a complementary endpoint under evaluation when we need incredibly fast, really query performance for exploration. But not all questions are best answered in pure RDF. Some of the use cases you saw earlier, for example, to analyze the graph with some algorithm, who connects communities, what are the cluster or what are the shortest paths, are network science questions. So to answer those, GRAPHIA adds an analytical backbone using a label property graph with Neo4j. This allows us to run graph algorithm for community detection, centrality, and similarity. But the boundary here is strictly enforced. The analytic graph is just a downstream projection. RDF remains the absolute source of trust, and Neo4j acts purely as an operational compute layer with no write back. But of course, before any of this can be queried, we need the factory in front. That's why we have a data acquisition platform in order to build the knowledge graph of GoTriple. It ingests normalized data, run the enrichment services, extract entities, and publish the result into the RDF core. It's entirely microservice-based and orchestrated asynchronously through different mechanisms. But finally, something very important, and because many of these stories are cross-source by nature, GRAPHIA doesn't try to copy the world. Through our federated gateway, as you can see on the right, we can query external partners directly, which bring us right back to the power of that interoperability framework. So a key important outcome from GRAPHIA is to build the GoTriple knowledge graph because it will be based on the GoTriple discovery platform with several millions of publication or other entities from SSH. Not only publication, of course, we are working with dataset, software metadata, semantic artifacts, etc. Different research scientific resources. But we absolutely need also to be connected, to be federated with the other existing knowledge graph and initiative. Open citation, AHI collection graph, ORKG, JSIS, exactly as you have seen in the previous example. So to do that, and thanks to this interoperability framework, we are building this federated gateway in order to let the end user on the right, as you can see, perform some query on top of everything to get some answer without any idea of the complexity behind, including thanks to natural language query. Our key objective, one of them, is to let the end user perform a natural language query just before the federated gateway, and to get some result from the GoTriple knowledge graph, but also from the other one, without any complexity items asked to them. And something I would like also to mention is we are building some RDF. The federated knowledge graph, as you can see on the diagram, are based on RDF, but we can also use the federated gateway to discuss with graph not only based on RDF, not at all. We don't need it. Thanks to the SKJF standard, we will be able to discuss between different kinds of knowledge graph, including the label property graph, which is another nature, for example, Neo4j, if we want to be connected, and if another knowledge graph wants to be part of this federation, It could be also possible even if you don't have any triple store, I mean RDF database to provide and to be part of this ecosystem. So maybe to conclude, if you want to go further, this is where everything is formalized in this deliverable, which is the GRAPHIA ontology. It describes the common semantic backbone we use to make very different SSH graph interoperable by aligning with skgif, as I have explained. And it also shows how we captured requirements as competency question and use them to validate the modeling and the federation patterns. You can scan the QR code to access the deliverable. And of course, we have also the technical ones, but it's not the purpose for today. If you are interested to get more details about the previous element I have shared through the diagram, we will have also other upcoming webinar to dive into some details, especially about the AI thing and how we can make this natural language query possible. But I invite you to follow the next webinar about it. And also, I would like to share with you, before we move to the question, one quick invitation. If you would like to help shape how search should work in GRAPHIA, Georgia and Crystal are running a short code design workshop today at 3 p.m. with no prior knowledge needed. It's just a quick end session on Miro. So the meeting link is on the slide. And we will also drop the link in the chat so you can easily join if you are interested to participate from your own perspective. So that's all for me for this presentation.